Here's the first of the differential equations where the differential itself is actually the original function. So it's one of those exponential ones that I mentioned back in the very first video. So let's see how we handle these. There's a couple of different approaches. The first approach I'm going to show you for the first 2 or 3 examples is the way the book does it. After that, I'm going to show you a slightly, what I think is a better way. But just so that you understand the setouts in the book, I'm going to show you what they do. Here's the approach that the book takes. It takes this particular fraction here and inverts it to start with. Now, the reason it does that is if we were to perform integration now, we end up, instead of y being a function of y, we end up having x as a function of y. It actually makes life a little bit easy, so we'll see how we go. So once I've got the differential on this side, if I integrate it, I end back up as x as my function. Now it's going to be in terms of y, so I need to integrate that. I'm integrating that with respect to y. So you have a 1-on function, and we know that when you integrate a 1-on function, it produces the natural log. So we know the natural log is written as the natural log like that, but I'm going to write it in this fashion just for the time being. It's the log of y base e. Now, so logs base e are natural logs. So I'm just writing it like that so that the next couple of steps becomes a little easier to see. So I'm now going to rearrange this one. So I've taken my differential function, and instead of working out some function y in terms of y, I've now inverted it, integrated, I've got some function x in terms of y. I'm going to rearrange to make this equation read y equals. First thing I do is take the plus c from the right to the left. Now, turn from a log statement to an index statement by taking the e to the power of x minus c, leaving with y on that particular side. Now from there, this e to the x minus c, let me just rewrite it over here. So that means, go back to our index laws you did last year or in year 10 as well, it's e to the x multiplied by e to the negative c. Now, e is just a number, 2.71828, etc. Raise it to an index, still just gives me a number. So all this is just a number. Might be a messy, ugly, horrible number, but it's just a number. So what I'm going to do, I'm going to say that this line here is equal to a lots of e to the power of x, where a is equal to e to the negative c. It just simplifies things a little bit. So I can rewrite this now as y is equal to a lots of e to the x. I've taken my differential equation and worked out what the original function was. So my steps were, step 1, invert this differential statement. Integrate both sides, I end up with function x. Integrate that, end up with my natural log, and just rearrange it to make it read y equals. So there's example number 1. I'll clear the board and I'll come back with example number 2. So here in a second one, once again, my differential is still some function in terms of y, but there's a trig thrown there as well. So first of all, this tan y, I'm going to make it into something that's going to be a little easier for us to use. Now we know that tan y is equal to sine y on cos y. I'm going to do that replacement. Same as before, if we invert this statement here and have dx on dy, I'm now going to do integration and I get some function x that's going to be written in terms of y. From there I'll rearrange it to make it read y equals. So integrating this side with respect to y, I just have the function x and I have to integrate here. Alright, very good. This looks very messy, so I'm going to simplify things a little bit. What I'm going to do, I'm going to do a replacement. I'm going to let u be equal to the sine of y. this is going to use this for my replacement value. I'm going to do a differential of u with respect to y. To give sine differentiates to cos. Fantastic. So what I'm going to do is I've got x is equal to the integral of cos y over, taking sine y out and put u in its place. When I'm now doing integral, I've got two variables here, and that's a problem. And it's with respect to y. But I've got this u. So what I'm going to do is I'm going to take this dy out and put a replacement value in, which I'm going to get from over here. I'm going to rearrange this to make it read dy equals, so bring it to the right, cos y comes back to the left. Every time I see dy, I can replace it with this. Hey, I have cos y top and bottom can cancel out, so I'm now left with the integral of 1 on u du. And we know that 1 on u is going to integrate to be the natural log of u plus c. Right, we're at the same situation that we were in the last one. We're now going to rearrange that. I need to take u out, put its appropriate value back in, rearrange it to make it read y equals. I'm just going to clear the board a little bit and then I'll finish it off. Okay, here is my situation. I've taken the u out, I've put its value back in. I'm now going to read y equals. Bring the c over. Change from a log statement to an index statement. Once again, I can deal with this minus c up here in the index. So a to the x, where a is e to the negative c, and then y is the inverse sine of this. Inverse sine, arc sine. So there is my function. Now I've rubbed the original question out, so we had our differential was equal to tan y. So by rearrangement, I'm now able to work out what function y actually is, and function y is that statement there. Okay, I have another question for you. I'll do that on the next video. I'll see you then.